Welcome everyone to the overview of our project, the TensorFlow and Neural Networks for Visual Art Generation. We are three people contributing towards this project. My name is Amay, and along with me is Gurjit and Deepika, who have contributed. I and Gurjit will be going over the project overview.
So this is our problem statement, how we can enable an artist or a painter. So artist and a painter can have like a style image, and he can implement that style to any image to get visual art in front of the artist.
So this is the main highlight of our project. We have the content image and the style image, which is passed through the VGG model, which is a pre-trained model. The contours of the content image and the texture of the style image is mixed together, and we get the final visual art image.
So this is our project highlight. We have this project in section 1, section 2, and section 3. In section 1, we have the style transfer technique, and then we have the color transfer technique. In section 2, we compare the different optimizers, and in section 3, we will work with the multi-style technique.
So here are the list of technologies of big data tools and other platforms that we used. The first is the TensorFlow, which is Google's next latest tool. The second is the deep convolution neural network, along with Keras API, which simplifies the usage of deep neural networks. Then we use the Amazon EC2 instance with 8 GPU, and the Amazon machine image that we use was Udacity DL. Along with that, we used the NVIDIA Tesla GPU K80, which was used for fast computation. To transfer data between the local machine and AWS, we used FileZilla. And an alternate platform to initiate AWS instance was Floyd Hub. And we have coded our entire project in Python 3.5, which came from Anaconda 3. And we used Cygwin to do some commands execution interface with AWS.
So in the visual style, the style transfer technique, we took a style image and an input image, and we were getting the final image, something like this. Here the color are being transformed from the style image to the final image. So there is no color transfer technique used. When we use the color transform technique, we were able to get the output image that has a similar color as the input image. And this is another.
So here you can see how the comparison has been made with the style, with the color transfer technique and without color transfer technique. So we have it can be clearly seen on the first top image that the style color is transferred, and on the bottom image the style color is not transferred and the content image color is preserved.
Here we compare the different optimizers in our project. These are some of the optimizers which we have used.
The various optimizers we used was to reduce the loss, and have a good accuracy on time. Here are the different optimizer output, and from the output you can see LBFGS optimizer was the best because it gives like sharp contours and proper textures.
And these are the graphs we got from the TensorBoard that explains.
This is the comparison of time versus the loss for different optimizer, and LBFGS, as you can see, completed all the 400 iterations within 300 seconds, and that is why the best optimal optimizer for the visual art generation.
And this is the loss graph, the scalar summary from the TensorBoard. And this is the histograms we got from the TensorBoard.
For multiple style visual art, we tried several attempts. We tried 10 epochs with 5,000 iterations, and it took just for 2,000 iteration 2.5 hours. So we estimated it might take 50 hours. We exhausted all the AWS credit, and as you can see here in the image, style 1 and style 2 is combined here. And just after training until 2,000 iterations, we got a very blurred image. So a second attempt was made to reduce the number of epochs.
In the second attempt, we reduced the images. It didn't work. We had like 24 hours. And in the third attempt, we even reduced the images more to 10,000 to 11,000. And here also, we can see we were getting a blurry image.
So as you can see, both the attempts were very difficult and it exhausted all our free credits from Harvard and plus $200 from our pocket. We tried to find a free platform which to AWS, which is Floyd Hub. It actually has a pre-trained model, but it didn't have for our style images a pre-trained model. So we tried to do a training on 100 images and combine the both style images with 50% weight. But since we had trained only on 100 images, the output could be seen as just the Chicago contour lines and a little bit of style transfer texture.
So we gained a lot of knowledge in this. We learned about the AWS, like how to use the AWS, how to change the instances, how to take the snapshots of the volume using the key value pairs. We learned about different tools here like Keras API, TensorBoard, and we also learned about the different very deep convolutional neural networks like VGG16 and 19, and we learned about FileZilla, and we compare different optimizers here, and we also learned about the Floyd Hub. And these are the references which we have used in the presentation. Thank you, everyone.
Thank you. Stop.